So today I'm looking at something a little bit different. This is a piece of rack mount gear. Interesting is it's from Siglent. It's an oscilloscope, a really big oscilloscope. Now this is the SDS6054L. I think the L is referring to the rack mount system, low profile. I don't know what the L means, but anyway. So it's a 4-channel scope. In this particular case it's 500MHz bandwidth. There are other models, I think it goes to 2 GHz, something like that. I have to check the specs, but I think it goes to 2 GHz is the maximum one. And obviously these are rack mounts. These are meant for production environments, which is really interesting in itself, the fact they're actually going towards that direction. We've got a digital 0 to 15 input here, so it's got logic analyzer function as well. A couple of super speed USB ports on the front. Cable port for checking the probes. We've got electronic selection here as well, so obviously you've got detection of what the probes are. Maybe active probes are possible too, because they're 2 GHz. So there'd probably be power there. On the rear, a whole bunch of other stuff. Aux out, external trigger, 10 MHz out, 10 MHz in, AWG, that's just an option. Micro SD port, HDMI, because you need to see what you're doing. More USB ports. So this has actually got 5 USB ports. Obviously you've got this one here, which is probably host. And then you've got the other 4, which is brilliant. Normally the Siglent scopes don't have enough USB ports on them, or Siglent devices in general. They might only have 1. And sometimes you want 2 or 3, depending on what device you've got. So yeah, it's nice to see so many USB ports on it. Hard power switch, IC connector. Now I'm actually going to be doing a teardown on this as well. Rob's given me permission. He said, yep, do a teardown, pull it apart. So that's what I'm doing. So this is on loan from Rob from Technology. I should mention that. I do not own this. tailtech.co.nz if you're in New Zealand and you're interested in this kind of equipment. So that's that. And the big box, it's got more gear in it. Quick start guide thing in there, as you'd always get. Look at the manual stuff online, the website. If you want to look at more about these. Got 4 passive probes, 500 meg. My cat's lost me. And she can't hear me, so I can't call her. There's a 500 MHz passive. We've got some handles for the front. Got some more screws or something. Don't know what they're for. There's the wings for the rack mount. Power cable, USB cable, mouse, because you need a mouse to control it. Calibration cert, it's, usual verification. Calibrated against the 3.2 GHz oscilloscope. Your 3.2 GHz oscilloscope calibrated workstation. That's a mouthful. And it's got these various specs in here which actually give you actual values. That's nice. Don't normally get that. Don't normally get actual values. So it's actually quite nice to have actually included those. Yeah, read through those in your own time. I'm not going to read them right now. You get a standard Pro Pack with reverse adjustments, things like that. But one thing it's actually got on here, it's got this protection sleeve which seems to just go over the top just to protect the tip. So if you're not using it, it actually means you've got no probe sticking out. It's unusual, I haven't come across that before. And these actually feel like really nice probes, so they're 500 MHz, like I said, passive probes. And it's the SP3150A. And you can see there's little caps in here for fine adjustment. And you've got the main calibration adjustment there for the compensation. But it's got the usual pack in it, you've got the various probes, and it's got these little rings as well. So put the rings on. Let's know which probe you're using, don't we? Need that. So there's the specs for the probes. You can see what they actually are. These are 10:1 fixed probes, which is not unsurprising because of the frequency these things go up to, the actual bandwidth. Impedance profile, you need to know that. That's also handy. Derating curve, also normal. Compliance details. And also, this little probe bag, it's actually got a spare tip in there too. It's quite nice to get a spare tip. So I think I'm just about ready to try this thing out. I'm just about set up. I haven't powered it up yet. The probe puts up to the front here, ready to go. Really nice quality it is actually. This whole thick assembly here feels really nice. It's a nice tight fit. It feels really good quality. It's really nice. This is just one of my mice. This is the one that came with it. The one that came with it is like a Bluetooth mouse. I don't know if it actually does come with it, whether it's something Rob supplies. I'm not quite sure if that's not standard thing or not. I've got a little 10-inch HDMI monitor sub over here just to do initial testing. What I might end up doing is going to screen capture instead and looking on a computer screen and looking at it that way, because you get a much better view. So I might just initially just look at this, just do some testing, then we'll change over to probably do a screen view like that. You don't get the mouse pad, that's mine. So let's power this thing up for the first time. It's the first time I've even used this monitor. I've never used the monitor before either. I've had this sitting around for ages. So there's that. We've got the power switch on the back. Turn it on. And then we have a soft power button over here, which is currently illuminated, which you can probably barely see. It's got some fans in it. It's got 4 little fans on that side. I'm not quite sure what this monitor's going to do. I might have to turn it on manually. Well, there's relays clicking and stuff, so let's turn the screen on manually. There we go. We found it. So what we'll do is we'll plug in the probe, do a probe conversation on this thing, and then we'll see what else happens. Well, there's the interface. I'll show you in a second. So I've now got the probe conversation hooked up. I've got it set up over here. That's looking actually pretty good already. So if you're not familiar with this particular interface, I'll show you some stuff on this, because this is basically exactly the same interface as I've got on my SDS2104 X Plus, and very similar to some other units as well, like the 5000 series as well, and I think it's all basically the same interface. So what you see on screen here is exactly what you get on these other scopes. So the GUI is apparently identical. It's just, you just pick it up and use it. If you're used to the other scopes, it's just like it's going to be easy. So there you go. There's a close-up of the screen, and as you can see, it's a standard Siglent interface. So you know, you're doing channels down here, on add channels, and turn them on and off here, and do the various math and digital and what have you down here. Memory channels, or you do channel options then in here in this menu, the vertical resolution, positioning, that sort of stuff. Also then you get the second menu pop up over here. You've got the coupling, turn it on and off. You can also turn it off over here. Probe type, in this case it's automatic because it's got 10 times probes, which it's got sensing on. You can set the labels up if you want to. 1 meg ohm, 50 ohm. I can actually hear relay switching there, so it does actually have 50 ohm inputs. Time base down here, adjust time base in this section. Trigger options in this section and up here. So it's all standard stuff. You can also hide the menu if you want. Utility menu, you've got various functions in here. Display, acquire menu, trigger, cursors, measure, math, analysis. So this is just like all the other Siglent scopes as far as the actual menu system, how they function. So that's really familiar. That's nice and comfortable. Bow plots, things like that. Also you need the AWG for that. I don't know if this has actually got the AWG in it. Let's turn the counter on. Having the counters on is always nice. Yeah, up there, counter. You can also display frequency, period, or totalizer if you want those instead. And back off again. The counter's kind of, I don't know, if you're not really using that function, you don't really need to worry about too much. But up here you've also got a counter. Okay, so you've got this one and you've got the other one. Power analysis, eye diagram, jitter. So I might go and do a screen capture and then try and control this from the computer and show you the web server part, because it's got web server as well. I need to set this up on my network. I need to plug the network cable in, and we'll go through that part. Actually, let's have a look at this thing. Utility, menu, I/O, coxels, nice. LAN config. So it's on IP configuration, which is DHCP. It doesn't say DHCP there. It just says automatic. It really should say DHCP because that's a standard terminology. Plug it into my network and we'll pop it up, and I can look at the web server side. Obviously this thing's built for use on a network, right? This is meant for being network accessed. I mean, at least I'm doing it like this directly with the mouse and the screen, but this is designed to be on the network and accessed that way. So I've plugged my network cable in. I had to close and reopen the window again just to get it to refresh, and it's detected my network, so that's all fine. So I will go and look at changing this. So I'm going to turn it off automatic. I'm going to change this IP address to something else. Okay, so let's go something else doesn't clash with 118, it might be right, I don't know. Click OK, don't click the X, click the OK. X is like cancel. Go back in, Yeah, that saved it, that's fine, that's right. Put it back to automatic because that's probably the best way of doing this. So I think it's going to pop back to 111. Yes, it has. There we go. That's fine. So let's go and look at this on our computer. So here we are on screen capture. So I'm capturing the screen. When you first go to the browser and you put in the IP address, right? So 192.168.5.111 in my case. That's what my IP address was as configured. And this is the screen you're greeted with, which tells you about the information about the actual unit. LAN configuration, so you can readjust it if you want to, but if you're already connected to it, why would you want to? Maybe you can use a password on it if you want for security reasons. Instrument control, which is where it gets more interesting. Actually, where we go back over here, it's got Skippy commands as well, so you can send Skippy commands like if you need to do a license update because you've got a new license for it, to upgrade it in some way, you know, extra features, whatever. You can actually usually do Skippy commands and send them this way. That's actually an easier way of doing it than putting it into the main interface in most cases. So back to the instrument control. Here we are. So this is what we want to look at. So this is exactly like the screen we're just looking at. This is the screen, and we can control it exactly the same way on the network as we can on the screen. Now, my mouse pointer does not show up, which is quite annoying. Fortunately, you can't see that. I maybe can see it if I click, maybe. But yeah, there's utility menu, which all those options there. Display menu. And when I click, the actual screen which is still connected to it is updating in real time. So as I click, it's instantly updated. So it is instant. So there's no real delay there. If I were to change the trigger source here, for example, make this much lower, really, make 50%. But okay, let's grab the trigger and drag it down here. So it glitches. And there we go. Well, it's not really glitching, it's more rolling. But what you're seeing on screen is just jumping around slightly. On the HDMI screen, it's actually rolling. You can see it rolling. So obviously there's an update rate thing going on. I don't know how fast the update rate actually is, but there you go. Anyway, let's lock it up again. So this is looking fine. So time base, let's look at the time base settings. Let's go, you know, make it faster time base. Let's look at these edges. You see the trigger point sitting over here right now. That blue marker is. You know, if I click here, maybe you'll see it. Also drag the level around as well if you want. But yeah. 2 microseconds, keep going down, 5 microseconds. So that response rate there is actually pretty good. So let's keep going down. What we go down to? 500 picoseconds is the fastest rate we've got here. Right, 500 picoseconds, that's nice. And the slowest is probably going to be, you know, milliseconds, I'm sure. So what I should actually do is plug in a test instrument I've got, which is the Leo Bodner pulsar. And we'll put that in there and check the actual rise time on this thing. So before we do that, we actually want to do measurements. So let's go in here, measurement menu. I could just do simple menus, that might be enough. Now this is set up on the wrong channel. We need to set these up on a different channel. Channel 1. Simple measurements, channel 1, that's what you want. Okay, but we've also got these other options in here. If you want to do types, you can manually configure exactly what you want to have. And these are just default ones. So we've got frequency down there, base, full time, rise time. Alright, so we've actually got readouts down here for those figures we want. So that's fine. Okay, that's what we want. So I've plugged in the pulsar now, and I've just changed it to 5 volts a division because it is maxing it out. Now I need to change the time base to get this thing on screen. So we're getting about 3 nanoseconds or so, 2.7 to 3 nanoseconds. So we call it 3 nanoseconds, shall we? And about 2.7 full time. So from that we can actually calculate what the actual frequency should be. So in a gigahertz you'll need to divide 0.35 by the rise time in nanoseconds, and that'll tell you the frequency in gigahertz that the bandwidth is capable of being. I think I've got my settings wrong. I've actually just moved the pulsar onto my other oscilloscope. This is my SDS2104 X Plus. Kind of, and this is the rise time getting on this one is 0.66 or so nanoseconds. So calculating the 0.35 divided by the nanosecond rise time gives me 530 megahertz or so based on this particular measurement. Okay, so this is what this one's doing. But what I've actually done, I think, when I've done the other unit, I've not got this configured correctly, have I? Because I haven't done things like put on 50 ohms or set the correct probe, because this is currently a 1-to-1 probe because of the fact that this is a direct connection. So doing these things will probably change the results. Let me go and plug it back in here. There we go, I plugged it back in, so we should now be able to get a better representation. Let's get a higher waveform, there we go. So this is a 490, I call it 500 picoseconds, of sort of saying 500 picoseconds rise time. So that's a bit different. So I've assumed 490 picoseconds, so that's 714 megahertz bandwidth based on rise time. And don't forget, this is a 500 megahertz version, and I'm sure that if you had a higher bandwidth version of this scope, that rise time would be faster. So yep, that's working okay once I get the setup correct, because I'm an idiot. So now injecting a AM modulated waveform. This is 10 megahertz signal with the 1 kilohertz approximately modulation on there of about 90%. So this is a part of the waveform we can see here. And if I change the time base, we'll see the waveform changing as we go through. So now we're getting towards the audio frequency part. There it is. There's the audio frequency part of the waveform. Now, if you want to raise the trigger up a little bit, we can do that. Just to help get a slightly better triggering. And we can also do things like delayed trigger and things like that. So we can actually get a nice waveform there. So that's looking absolutely fine, as expected. Now what I'm going to do is check the flatness of this thing. So we can check the analog bandwidth, not just the rise time, theoretical bandwidth. So there's two ways of actually looking at it, and I actually like to look at the analog bandwidth as well to see how flat it is across the range. So I'm going to turn the AM modulation off this thing. Right, so what I'm going to do now is go through a few different frequencies and monitor the actual amplitude. And I'm just going to go through and do it because I can't remotely control this device. Well, I probably could if I hooked it up to my network, but it's not hooked up. Now I've got the RMS value set down here. You can see the pointer there. Right, RMS value right here. That is set to 101 millivolts at 100 kilohertz, as you can see at the top of the screen beneath the Siglent logo, just up there. Unfortunately, you can't see the mouse pointer, which is a bit annoying. That's at 100 kilohertz, and as I go up the frequencies, watch out for that RMS value, and I'll let you know when we get down to that 3 dB point, which is the analog bandwidth of the scope. So I shall spin the mic around a bit, and hopefully you can hear me okay. So it's 100 kilohertz. Let's do 1 megahertz. You're seeing exactly 100 millivolts there. That's still good. 10 megahertz. So 101, still good. 100 megahertz. Let's change the time base on this. I'm using this remotely next to my desk, so I've still got the mouse over here, so I can control it from the computer and from the desk at the same time. Here we go. So let's do 100. That's nice. So 200 megahertz. It's doing 96 millivolts there. 300. 93 millivolts. 400. 88 millivolts. Part of this loss could also be the cable. Don't forget, the cable will have loss, but it will drop in slightly. That should be factored in really. So it's 500 megahertz, which is what it's rated at. It's doing 84 millivolts still. Let's do 600. There's 77. Not quite there yet. That's at 600 megahertz. So it's already exceeding spec. Let's do 650 because we're getting close. Still fine. 700. Don't forget we worked out 740 megahertz, wasn't it? 743 megahertz and bandwidth based on the rise time. Wasn't that correct? And we're right now at 700 megahertz, and we are at the 3 dB point right now at 700 megahertz. So that is exceeding spec. So that's pretty good. It's rated at 500. It's doing 700. Everyone should be happy with that. So now what I've done is I've hooked up the AWG from its rear output back into its front output. So we're actually going to use the AWG on itself. So I'm just going to reconfigure this to make sure it's all good. Yep, 150 ohms, that'd be right. So AWG, let's turn this on. Wave gen. Turn this on, set to 1 kilohertz, 100 millivolts peak to peak. Let's just change the speed slightly, shall we? There it is. If in doubt, assume you're an idiot. I'm still an idiot. AWG. Wave gen. Should be 2.82. Because I'm peak to peak, not peak. 2.82. There we go. So we should be getting 1 volt now. So I've just gone in and changed the analyzer settings because I actually had that set wrong because I didn't have a 50 ohm output set up on it. So that should change things a little bit. Now we'll come back and do this as 2.818. Where's 2.82? 2.82. Then we should get 1 volt RMS here or close to it. And we are. Alright, so that's right. So watch out for peak to peak versus output impedances and input impedances. Just this is currently set to 50 ohm as well, so to match them. If I set 1 mega ohm on here and 1 mega ohm on the AWG, it would have probably been fine. But anyway, that's not what we're trying to play with. We want to play the AWG. So, I mean, you can actually type frequencies in. I don't know if I can do it with a web interface. I've never actually tried. Can I do 100? I can do it with a web interface. Enter. There we go. 100 kilohertz. Great. That does work. I'm not sure what the maximum frequency is on this thing. Let's do 1 megahertz now. Let's go 10 meg. Probably 25 megahertz. I'm not quite sure what the actual maximum is on this thing. Should we do a square wave? Should we change the square wave and see what's going on here? Square wave. It's not very square. Let's just look at this before I forget, eh? Let's do 1 megahertz. That's kind of square. Yeah. Rise time on that square wave is 25 nanoseconds. Rise and fall time on 1 megahertz square wave is 25 nanoseconds. Okay. So now you know. Let's do back to 10 megahertz. Still the same rise time, and it's not looking like a square wave anymore. Square wave is limited to 10 megahertz, but it's not looking very square. Now, part of that could be the cable. It may not be a good quality cable. I don't actually know where I got it from, actually, to be honest. Anyway, let's go back to sine wave. So 10 megahertz sine wave, that's fine. Let's go 20 megahertz sine wave. That should be no problem, I expect. There we go, 20 megahertz. 25 megahertz. So there we go. The AWG is limited to 25 megahertz. But that's fine, I suppose. Let's do some pulses. What pulses can we get? 10 megahertz pulses. Okay. So it's the same limitation as a square wave. Let's make this a little bit slower. There's a nice pulse. You've got the roll pulse width there, 50 nanoseconds, apparently. It's never seen pulses at those timings. So yeah, I mean that's alright. AWG works fine. I mean rising edge, I'm not sure about that. That rising edge 25 nanosecond thing. So let's just look at doing a screen capture. So let's go to utility. And then here you've got print. Now normally on a scopes you got a print button, you just push that button and it will do a screen capture. So if I push this menu item, what happens? Menu disappears, and then we go, it's done a save. So that is actually working okay. The way it clears the menu away first is quite nice. So leaving it overhanging the screen. So that works okay. What display options have we got in here? There's persistence, clear display, full grid, light grid, yeah, all the standard stuff. Display menu. This is the same as all the other scopes. If you see me review the other scopes, then you'll probably be familiar with all this stuff anyway. It's not really surprising. I mean, vectors and dots, you want to see dots. In this resolution, it makes almost no difference. You want to see the sample points. Persistence is off right now. Hide menu, yeah, okay. That's all this standard stuff. Acquire menu, so look at that. So, interpolation, acquisition mode, acquisition type, memory management, auto memory management, max memory depth, 250 meg. What we got here, up to 500. So, what you actually get is if you turn more channels on, it might change. So, let's have a look, let's turn some more channels on. Let's turn them all on. And that one. And this one. Turn all the channels on. Now, what does that do for it? Acquisition menu. Max memory depth is 125 now. Yeah, so all 4 channels on, it's 125. That's still not bad. So what I actually might do is turn off channel 4. Check it again. Still 125. Okay. Then we'll turn off channel 2. Check it again. Now it's 250. So there you go. So obviously you've got a shared acquisition. If I turn off channel 3, back to channel 1 again. Mem depth up to 500 again. Whether it's interleaving 2 separate chips, I'm not sure. Maybe we'll find out when we pull it apart. I'm not sure if we actually see anything or not. So we can get up to 500 meg on a single channel, 250 for 2 channels. Well, I should check channel 1 and 2. I haven't checked that combination, have I? Check 1 and 2. And back to the acquire menu. And it's still 250 meg. So it doesn't matter which 2 channels you have on, you're going to have 250 meg. If you have 3 or more channels, then you can have 125. So, okay, good to know. Trigger menu, standard stuff. Different trigger types. You can choose which channel we're triggering from. Edge trigger, for example, or these other ones. All these different options you can use in here. Delay trigger, nth edge, all these other things which are quite common. Serial trigger's quite a handy one. Hold off is none in this case. That's actually good. Like when I was doing that 10 megahertz test with the AM modulation on it, if I'd actually turn on hold off, we would have got a stable trigger. It's usually around 800 microseconds, I think it was the actual trigger time, and that gives you a stable trigger on that particular one. But and you also got zone trigger as well. Cursors, well, yeah, cursors. I don't tend to use cursors very often. You know, sometimes it's nice, but lots of different options here for cursors. Measurements. So you've already looked at this a little bit. But let's go into the menu and look at all the types. Haven't looked at this in detail yet. These are all vertical measurements. These are horizontal measurements, and these are a whole bunch of other ones. This is in the simple menu. Does the advanced menu give you different options? Let's have a look. It does. So again, you've got the favourites, you've got verticals, which we had before, horizontals and miscellaneous. Then also got channel delay options as well. So these are slightly different ones. So yeah, it does give you different versions. So you're trying to measure those different things instead of those dual functions, you can do that. Math functions, you can actually assign a math function and then you can actually see it down here or see it on screen, but just like all the other scopes. So in this case, you're doing channel 1 plus channel 1. You could do other things. You could divide one by the other or do FFTs and all these usual things. FFT is quite a popular thing to see. Let's do an FFT, and here we are with an FFT of whoever thinks we were injecting. Is it 100 kilohertz? Of course, we've got this configuration like this, so it's just change the configuration. Horizontal bandwidth. I want to reduce this considerably. Let's go down to 1 megahertz. I don't want to start at 1.5 megahertz. I want it at... What's the lowest I can go? 1 kilohertz. Can I do that? Probably can. Yes. There we go. We've got a spike just here, which is around 100 kilohertz range. So let's change the ending frequency again. Let's go, I don't know, 300 kilohertz because we are injecting 100 kilohertz. And there we go. And now obviously our vertical resolutions are off here, so we'll change that. So let's go 0 dB as a reference. There you go. Now we've got it all on screen. So yeah, I mean, FFT stuff. I mean, you can do it. Turn it back off again. All sorts of stuff in here. Got decoding. Obviously, it's not much use on this particular signal because I'm not doing any digital decoding. Because you've got 4 channels, you can actually do things like SPI decoding and things like that. So you can actually use the analog channels to do decoding. Bus 1, bus 2 is the decoding buses. So the buses here, turn it on, and you can come in bus display. You can change how you want to display it. Obviously, it's displaying along the bottom of the screen right now. You've got hex, binary, decimal, and ASCII. And you've got the protocol decoding, so you've got the I2C and there's different protocols in there. The signals, channel 1 is doing SDA right now in this particular case. You can set the levels, SCO and SDA both on channel 1. So let's change that to that one there, and it's going to make complete garbage because it's not actually a signal. If you're doing a different kind of signal, you could change like it's to SPI for example, and then change the protocol signals on here, and you got one for each input. So you know, use channel 1 for that level. Yeah, MISO, MOSI, and chip select. So you've got 4 channel scopes, so you can set the analog channels to these and do decoding with the analog channels. Of course, if you've got the logic analyzer function, you can use those inputs instead if you have it. That's the channel 1 protocol config. You can change the configuration for it, and protocol copies. Copy for another trigger, for example, like a copy 2 trigger. So you want to trigger off that protocol, you can make that a trigger source. Alright, so that's decoding. I mean, I've shown these things loads of times before. You've got history mode, mask testing, DVM. There you go, DVM, turn the multimeter on. There you go, it's just giving a reading up here, and DC averaging or IMS. So you can do different modes like this. But if you've got this reading down the bottom here, you don't really need that. Not usually, unless you're trying to make the display a bit more compact. And it could have useful things. Turning trending on, so you can see what's actually happening to something over time. That could be handy. Bow plot, obviously you need the AWG for that. I don't know if you can use the internal AWG for bow plot. Yeah, so you have to, it looks like you have to use an external AWG for the bow plot. You can't use the internal one, which I find a bit weird. Like even my SDS2104 X Plus, that's the same thing. You have to use an external AWG, even though it has an internal AWG. It's a bit strange. Why can't you use the internal one? That just seems a bit weird. I mean, I call it bow plot. Is it a Bodhi plot? Bode plot? I don't know. Bodhi plot. Whatever name you want to use. Wait for this to catch up again. It's changing modes. Power analysis function, histogram, counter, which you looked at before, ideogram, and jitter analysis. So I do seem to have lost my channel 1 for some reason. Where's channel 1 gone? Is it because the AWG turned off? Let's turn the AWG back on again. It is. Turn it back on. There we go. Now we've got it. So back to jitter analysis. Not enough events apparently. Okay. Well, time base. Not enough events. No, I don't know how that works. Not something I've used, but it looks like it's something that could be handy. Obviously settings in here for this, but yeah, just to turn it back off again. Right, let's pull this thing apart. Let's have a look and see what's inside it. Rob's brave. I've got to try and get through the security seal without damaging that if I can. We'll see how that goes. I'll take this side off first so I can get to it, and then I'll spin it around and try and get the other side sorted out. Hopefully we can get through the seal using the trusty iFixit screwdriver. Screws on the back. Yep, there's a few on the back. 3 screws on the back here. Now, the seals. Can we get rid of these? I need a razor blade. Just take your screws out first, and I don't have to worry about trying to shove them out whilst dealing with the seals. There might be another screw under there. There is, there's a screw underneath this seal here. Right, razor blade. Let's try and get underneath this one first. Without scratching paint. There you go. There's that one there. Then we'll do this one. This is the hard one. Really carefully, just gently do it, don't rush. There's no rush, there's no time limit on getting this done. If the angle too shallow, you'll cut through the label. If it's too steep, you'll scratch the paint. So, take your time. There we go. We're in. How does the front come off? Does it lift? Does it hook? Does it slide? That's a really good question. There we go. It's moving. Okay, cool. It's off. The hook's in the front there, so you've got to slide it back to get those out. That's fine. That's what the inside looks like. Ooh. Right, there's the inside of it, so let's have a close look at this. I've already seen some interesting aspects about this thing. Now you can see I've taken some precautions, got some gloves on, and also earthed myself. So I don't often do, because I do this anti-static mass sitting here, so I don't actually normally need to do it, but in this particular case I'm going to be a bit more careful than normal. I'm going to be poking around and things like that, so bit of care. What do we see? We've got multiple boards for a start. This side we've got 4 fans. These come around to the logic board over here, or the main board over here, and there's actually a 5th fan connector. See, there's a 5th fan connector right there, so it's actually allowed for 5 fans, which is interesting. There's also this connector floating around here, which is a feedback from over here. So the power supply comes in over here, goes through the switch, goes to this board, It actually taps off to this board as well, which is interesting, and comes back into the power supply, which is obviously plugged in through here. And then you've got these other ones floating around here, so it's interesting. Maybe there's some option that you have on, who knows. Or maybe it allows for different versions of this unit, because there are different versions of this. Some have got, I think it's 8 channels, I think that's right. So maybe they need this to piggyback different boards, because there's like a 2U rack version. This is obviously a 1U rack, but there's a 2U version, which has got more features. So maybe that's meant for that, so it's universal. It could be. So there's the AC board here, which is coming in. And we've got this daughter board here. This has got the trigger input and output and Ethernet and things like that on it. HDMI. And it's obviously coming across via these flexes here. Okay, so that's those ports there on the back. Then we've got this other daughter board here. This is the AWG. The AWG here is on this daughter board. So maybe if you get this thing without the AWG option, this board may not even be populated. I don't know. I would have thought they put the hardware in there, but they may not. And interestingly, it's only got one wire running across the control that board. This one right here. Sorry, it's got 2 wires. It's got this one, which goes to the output, and the other one comes across here. And it's actually marked as USB AWG on the board, just there. But it's got 5 wires, so yeah, it's probably got a DC ground and a analog ground, maybe both. CR2032 battery here, memory backup. And interestingly, another USB port here, and a USB port here. So maybe they were thinking that they could have a plug-in USB unit, just plug it in, rather than having a header. I don't know. There's a few little interesting things like that in here. We've got some programming header or something up here. You've got TXRX ports there. Something here which is marked as key. I don't know. Got this flex here which comes across to the front panel. There's a little buzzer, little sounder thing there. It's obviously power supplies and things like that around the place. So it's got some processor here, got some memory. Main processor over here. Big processor right here. And you've got the 4 channels coming in here. So I might actually pop one of these off and have a look. Look like I should be able to pop one of those off without any damage. Other interesting things. You see the socket right in the middle of the board here? That's marked LCD. Very interesting. And also, just behind it, behind its wires, you can't really see, but just there, there's a connector, which I think is probably an extension for the LCD connector. So I think it's like an external LCD connector. So it probably has provision for a screen. That's interesting. Also got another weird connector just here, which I can't actually see what that is. Some weird thing. So we've got some RF cables coming in here, you can see. We've got these SMB connectors, these little plug-in ones. And the interesting thing about this is that there's a bunch of them. Now the rear of this unit's got 2 connections for 10 MHz in, 10 MHz out. And just down here we've got some options. We get closer. So these are the 10 MHz in and out, right? 10 meg in, 10 meg out. You can just see the 10 meg out marking on the board there. Here we've got a 2U ref clock in, 2U ref clock out. So this is obviously meant for the 2U unit, which has got the extra channels. So it's obviously daisy chaining or something, I'm not quite sure. Then we've got a 3.9 meg skew test point. I think that's a test point because it says TP. I think there's other ones here. PE 100 meg N, PE 100 meg P. Curious. So we've got a few little things there, and obviously unpopulated header as well. Over here we've got another connection which is marked as what? Power monitor. That goes back to the power supply. So it's your feedback for the power supply to see what it's doing. We keep looking around. A bunch more power supply stuff. A lot of things are actually labelled, it's quite nice. And what was I going to show you before? Something else I saw which is interesting. So the programming header is over here as well. There's one there. And there was one up the top, up here. And so that one there, so I already pointed out before. So there's a few programming headers around you can probably hook into. Now, obviously the channels are one of the things we want to look at, but it's behind this metal shield here. I can't get to that to get it out without taking the board out of the chassis, and that's not something I want to do. Yeah, the only way to get to that is take the board out, and I don't want to go there. I don't want to take the board out of the chassis. So that's going to stay as it is. We're not going to look at those. This looks curious. Hand soldered. That's interesting. This is power supply section. It's got some hand soldered capacitors in here, like they've had to try and tune it for noise or something. And these two actually blob together. Those are stuck together. So do those. I mean, they're probably the same power rail anyway. It probably doesn't matter. Yep, that's just power rail strips. So it's probably a plus and minus supply or something like that. So I've obviously done some work on this to improve the noise rejection, to filter it out better. I'm just surprised it's that messy. I was surprised they would clean the flux up. Other headers we got in here, we've got some more in the middle of the board. A couple more over here. CPLD. And I don't know what that is. Maybe useful to someone. Unpopulated chip. But it's interesting, the AWG is basically a USB device. I mean, you have to wonder, you can get those external AWGs for doing the bow plots, or Bodie plots, if you want to pronounce it. In those little boxes they sell. I wonder if that's actually that AWG, and they just left it outside the box. Don't know, never seen inside one, maybe. So what I think I'll do now is try and get some photos of this, some decent high-res photos, and try and get it nice and focused and stuff like that. Maybe there's something in here which you want to see underneath for these flexes or something. Maybe there's a reference point you need to know. So maybe it'd be helpful for someone or something. Anyway, we'll see how we go. So there you go, that's that done. I'm going to put this thing back together now. Check out the other videos down below for things you might be interested in. Subscribe over there if you're not already subscribed. Patreon support link over there if you want to help support the channel. Helping to buy bits and test gear to fix and that sort of stuff and things to make videos about. Catch you later. Click subscribe right now, quick, before you forget.